Jacques Couel was one of the most interesting French architects of the 20th century. He was a friend of Picasso and Dali. His buildings are Gesamtkunstwerke, artworks in themselves. Every little detail, including the sandstone tile floor, is an integral part of a fantastic whole. The most striking part inside this building is a huge painting by the Belgian artist Gustave Signet. He participated in Documenta 1 and Documenta 2 in 1955 and 59, along with Picasso, Jackson Pollock, Rauschenberg and Rothko, to mention just a few. The canvas is glued onto 20mm plywood and painted with acrylics. It measures almost 4 meters across, and it is anchored into the wall and embedded in gypsum plaster. The painting is dated and signed. In autumn 2014, we inspected it for the first time and found the beech plywood was actively infested by a wood-destroying beetle. Even though the hatching season was already over when we arrived, we found some fresh wood frass underneath the painting and a few dead specimens in the room. There were thousands of exit holes in the canvas. It is possible that this infestation had been active for decades, as this particular beetle is philopatric. Many generations stay in one and the same objects. This can result in total destruction if no action is taken to kill the insects. The larvae of the beetles had bored a gigantic tunnel labyrinth just between the top layer of the panel and the canvas, turning the wood into powder. In some spots the damage was severe, culminating in loss of substance. Partially the canvas and paint were gone, not to mention the wood itself. We had hoped to be able to pick from a number of options of how to deal with the painting. One of the options was to remove the canvas entirely from the panel and restore it in the Brussels iPark studio. But given the condition of the canvas, this was far too risky. The canvas had been completely eaten up in some places, leaving behind just the primer and the acrylic paint. The most affected part in the painting was the top left corner. Here the canvas looked like a sieve. During the preparation, we had covered the canvas with Japan paper as a protective measure. It just so happened that the beetles started exiting the object when we started working on it. Thanks to the Japan paper, we could tell which holes were new and which were old. This is, by the way, a common method of monitoring suspected or real insect activity. Before the treatment, we counted 10 to 17 new holes per day. The highlighted areas show where exit holes were particularly numerous. The whole painting is made up of 3 individual boards, joined by tongue and groove. A secondary localization of exit holes was found along the seam of these joins. With the right light, you can actually see the imprint of the seams in the canvas. The painting is held in place by several steel brackets and a row of reinforcing nails which grip into the plaster. The most common beetle from the Anobridae family is Anobium punctatum, which every conservator has come across in his professional life. This one looks similar, but is in fact Nicobium castaneum. It lives on wood, paper, but also eats leather and parchment, which explains why it is sometimes referred to as library beetle. It does cause great damage in older books. Nicobium castaneum is found in all of Western Central Europe, but seems to feel very much at home in the Mediterranean. This is a true classic, the proverbial Chapter 1, Page 1, Paragraph 1 in any IPM standard book. Decorative firewood sharing a room with art. Firewood is often infested, and it should be used appropriately. Burn it, and burn it fast. As if to confirm the risk we just described, we actually found a so-called cross-infestation in an artwork. It is one thing to have beetle larvae in firewood, but it is an entirely different story if the destructive insects find their way into pieces of art. In this case, the damage wasn't severe, but it could well have turned out just as bad as in the Sinjay painting. Once the scaffold was set up, the canvas was covered with PE foil. As the painting was embedded in plaster, with the plaster overlapping the edges, we needed a template to be able to always know the exact shape and position. Japan paper was attached as a protective layer, and the plaster next to the painting edges was chipped away. We kept count of the newly emerged exit holes, killed all the beetles we could find, and vacuum cleaned the place regularly. 3 factors: the hatching beetles from the painting, the firewood, and the cross-infested Rothschild, led to our decision that all wooden objects in the building should be treated preventively, now that we and the machinery are there anyway. We shall see more about the preventive treatments later on. We had learned that there was no way to either take the entire painting down nor to remove the canvas from the wall, which left one option only: to treat the painting where it was, on the wall, in situ. So we built a temperature-insulating and moisture-tight enclosure around the painting. For this we used special foil reinforced with a timber construction. The tent is based on the concept of a regular Thermo Lignum climatic chamber with the same sensor infrastructure. 4 room temperature sensors, a core temperature sensor, and a sensor to measure the relative humidity. The closed air circulation is managed through 2 large air ducts. The tent must be hermetically sealed to avoid the formation of condensation. In fact, this tent was insulated so well that we didn't find a drop of condensation after the treatment. The ventilation unit and the electronic control unit were placed in the garage, as the distance to the painting wasn't far. The air ducts should be as short as possible, so as not to waste energy. The heart of the Thermo Lignum processor is the so-called PLC, the Programmable Logic Controller. This is actually built into the electronic control unit. The laptop PC is just there to set the parameters and visualize the climatic conditions inside the tent. Except for the airflow noise, the treatment itself is rather unspectacular from the outside. But there's a lot happening on the inside. The Nicobium beetles and larvae and eggs are killed. The parameters for each treatment must be set individually. In this case, the relative humidity was set to 50%, and the maximum room temperature was around 55 degrees centigrade. The 55 degrees centigrade were maintained for an hour only. After about 24 hours, the tent and all the sensors were taken down. And yes, we did find some dead Nicobium specimens, which had exited and dropped to the floor during the treatment. Obviously, we monitored the painting even more thoroughly during the following days. No more holes emerged. The treatment had been successful. The Japan paper was removed, and the painting surface was cleaned with demineralized water. A lot of dust and grime had collected over the decades. The loose or broken parts in the canvas were glued with BEVA film and reinforced with non-woven polyester fabric when necessary. Using the template, the gypsum around the edge was replastered. Great care was taken to model the plaster according to the original appearance. The exit holes were all filled with a custom-made BEVA filler. The new plaster was painted with matte white acrylic paint. All retouching executed with pigments with a medium of paraloid B72 in 25% diacetone alcohol and 75% ethanol. This part of the job was done. We had decided earlier that all objects in the house prone to insect attack should be treated preventatively. And who knows, perhaps some of these objects had actually been infested. The trouble is that you often can't see from the outside if there is an infestation or not. So we built a second tent in which we treated all furniture and other wooden objects. Some of the furniture were upholstered. The Thermo Lignum method was actually developed 30 years ago with a focus on antique furniture. By now, it is used to treat almost any organic material in collections and museums, be they wood, textile, paper, leather, polychromatic objects or paintings. The work by Judith Rothschild was treated separately as the maximum diameter was only around 12 millimeters, so this treatment was quick and the exposure to elevated temperature was very short.